Earth Science, Chapter 6, Section 3, Energy from Petroleum and Natural Gas. Digging deeper. Petroleum and natural gas as energy resources. The nature and origin of petroleum and natural gas. Petroleum is also called crude oil. It is a liquid that consists mainly of organic compounds. Its organic compounds range from fairly simple to highly complex. Natural gas consists mainly of a single organic compound. This compound is methane. The chemical formula of methane is CH4. Oil and natural gas are useful fuels for several reasons. They have a very high heat content per unit weight. They cost less than coal to transport and are fairly easy to transport. Oil and gas can also be refined easily to form many kinds of useful materials. Both are used as the raw material, called feedstock, for making plastics and other synthetic compounds. For example, they are used in paints, medicines, insecticides, and fertilizers. Natural gas is also a raw material used in antifreeze, clothing dyes, photographic film, and explosives. Oil and natural gas are found in the pore spaces of some sedimentary rocks. The raw material for the generation of oil and gas is inorganic matter deposited along with the sediments. It is made up of the remains of tiny plants and animals that live in oceans and lakes. These organisms settle to the muddy bottom when they die. Much of the organic matter is oxidized before it is buried. However, large amounts are preserved and buried along with the sediments. As the sediments get buried more and more deeply, the temperature and pressure increase. This causes some of the organic matter to be changed into oil and gas. Petroleum geologists use the term maturation for this process. They call the range in burial depth that is right for generation of oil and gas the oil window or gas window. They call the regions rich in organic matter subjected to these depths the kitchen. Depending upon the details of the maturation process, at times mostly oil is formed. At other times, mostly gas is formed. The mudstone and shale that form the source rocks for oil and gas are impermeable. Fluids can flow through them very slowly. The oil and gas rise very slowly and percolate through the source rocks. The gas and oil are less dense than water. Water is the main filler of the pore spaces. When the gas and oil reach fractures and much more permeable rocks, such as some kinds of sandstone and limestone, they can move much more rapidly. Much of the oil and gas rise all the way to the Earth's surface. Here they form oil and gas seeps and escape to the atmosphere or produce tar mats. If the rocks are capped deep in earth by an impermeable layer called a seal, the oil and gas are prevented from moving up. A large volume of porous rock containing oil and gas with a seal above is called a reservoir. The oil and gas can be brought to the surface by drilling deep wells into the reservoir. This is shown in Figure 2. Petroleum reservoirs around the world range in age from more than a billion years ago to just a few million years old. I apologize. This is shown in Figure 2. Petroleum reservoirs around the world range in age from more than a billion years to just a few million years old. Geologically, this is very young. Oil and gas are considered non-renewable resources. That is because the generation of petroleum operates on time scales far longer than human lifetimes. Porosity and permeability. Most sedimentary rocks have open spaces in addition to the solid materials. These open spaces are called pores. Sedimentary rocks are the most porous rocks. Think about what a sandstone looks like on the inside when it is first deposited by flowing water. The sand particles are in contact with one another in the form of a framework. This framework is much like the way oranges are stacked in the supermarket, except that the sand particles usually have a much less regular shape than oranges. Porosity is a measure of the percentage of pores in a material. It is defined as the volume of pore spaces divided by the bulk volume of the material multiplied by 100. It is expressed as a percentage. The porosity of loose granular material, such as sand, can be as much as 30 to 40%. If the sand particles have a wide range of sizes, the porosity is less. This is because the smaller particles take up the spaces between the larger particles. The sand slowly becomes buried in sedimentary basins to depths of thousands of meters. There, temperatures and pressures are much higher. New mineral material called cement is deposited around the sand grains. The cement serves to make the sediment into a rock. The cement in sedimentary rocks is not the same as the cement that is used to make concrete. However, it serves the same purpose. The addition of the cement reduces the porosity of the rock. The most productive petroleum reservoir rocks are those in which the pore spaces are not isolated. When the pore spaces are all connected to one another, fluid can flow slowly through the rock. Fluid flows through a porous rock when the fluid pressure differs from one place to another. The rate of flow through the porous material in response to a pressure difference is called the permeability of the material. For a rock to have a high permeability, it generally has to have high porosity. However, the pores must be fairly large and also well connected with one another. Good petroleum reservoir rocks must have high porosity to hold the oil or gas. They must also have high permeability so that the oil or gas can flow through the rock to the bottom of a well. Some reservoir rocks are highly fractured. The oil and gas can move along open fractures as well as through the pore spaces. Fluids also flow in porous rocks because of differences in density. Most sedimentary rocks deep in earth have their pore spaces filled with water. When droplets of oil or bubbles of gas are formed in the rock, they tend to rise upward through the pore water. They do this because both oil and gas are less dense than water. Only when they are trapped and accumulate beneath a seal do they form a petroleum reservoir. For a mass of rock to form a seal, it has to be impermeable. In its simplest form, it also has to have a convex upward shape, like an umbrella. It is usually much more complicated in its geometry than an umbrella. However, excuse me, it is usually much more complicated in its geometry than an umbrella, however. Just imagine raindrops falling upward into the inside of your umbrella rather than downward on the outside of the umbrella. The vertical distance from the top of the seal to its lower edge, where the petroleum can spill out, is called the closure of the reservoir. Giant reservoirs of petroleum can have closures of many tens of meters. They can also have horizontal dimensions of thousands of meters. Reservoirs that large can hold hundreds of millions of barrels of oil. Recovery of petroleum. Oil and gas are removed from reservoirs by drilling deep wells. At greater depths, the wells are only a few inches in diameter. However, they can extend down for as much as several thousand meters. The technology of drilling has become very advanced. Wells can be drilled vertically downward for some distance. Then they can be diverted off to the side at precise angles. This is called directional drilling. Holes as narrow as 6 inches can extend horizontally 5,000 to 10,000 feet into layers. In addition, horizontal drilling allows for multiple wells to radiate outwards from a single drill pad. Sometimes the oil is under enough pressure to flow out of the well to the ground surface without being pumped. However, usually the oil has to be pumped out of the well. The pumping lowers the pressure in the well. The oil then flows slowly into the well from the surrounding reservoir. Much of the oil in a reservoir remains trapped in place after years of production. The main reason is that oil adheres to the walls of the pores in the form of coatings. The coatings are especially thick where several sediment particles are in contact. There, the pore spaces narrow down to small throats. Several techniques are used to recover some of the remaining petroleum, called secondary recovery. One of the most common methods is to inject large volumes of very hot steam down into a well. This makes some of the remaining petroleum flow more easily into the well. Since its discovery, oil has been produced mainly from rocks with high permeability. As this oil has become depleted, petroleum geologists have begun to look for oil in reservoirs with low permeability. Tight oil, also called shale oil, is oil that is trapped in low permeable rocks. Tight oil can be found in oil-rich shale layers as well as low permeable sandstone and carbonate rock formations. In order to increase the amount of oil produced from low permeable reservoirs, more specialized techniques are used to recover tight oil. For example, similar to secondary recovery, large volumes of very hot steam are injected down into a well in order to allow tight oil to flow more easily. Another technique is to create artificial fractures in the reservoir that connect to the well. This increasingly popular approach for oil and gas recovery is known as hydraulic fracturing or fracking. Fracking involves using water pressure to open fractures in the reservoir. This is done very precisely. Operators monitor the growth of the fracture network. They do this by looking at the pattern of tiny seismic waves caused by rocks breaking. Once the fractures are open, sand or other particles are injected into the reservoir. This lets natural gas and oil escape toward the well. After pumping, the fractures close and the pressure subsides. In 2015, about half of the 9.1 million barrels per day of crude oil in the United States produced came from fractured, enhanced wells. And analysts have calculated that fracking could unlock over 100 billion barrels of new global oil supplies. The history of oil production in the United States. The use of energy in the United States has changed over time. The burning of wood to heat homes and provide energy for industry was the main energy source in about 1885. Coal surpassed wood in the late 1800s. Coal was then surpassed by petroleum and natural gas in the 1950s. Hydroelectric power appeared in 1890. Nuclear electric power appeared in about 1957. Solar, photovoltaic, advanced solar thermal, and geothermal technologies also are recent developments in energy sources. The appearance of petroleum and natural gas has been the most striking. There has been an overall pattern of growth, excuse me, there has been an overall pattern of use during this time. This pattern has been that of exponential growth. The first successful oil drilling venture was Colonel Edwin Drake's drilling rig in 1859. It was in northwestern Pennsylvania. Drake reached oil at a depth of 70 feet. Petroleum was boosted with the discovery of Texas's vast Spindletop oil field in 1901. As automobiles became mass produced, use of oil began to grow more rapidly in the 1920s. In the years after World War II, coal lost its position as the leading fuel in the United States. Trucks that ran on petroleum took business once dominated by railroads. Railroads began to switch to diesel locomotives. Labor troubles and safety standards drove up the cost of coal production. Natural gas began as a source for lighting. Gas lanterns and streetlights used natural gas. It then replaced coal in many household ranges and furnaces. By 1947, use of petroleum and natural gas was greater than coal. It then multiplied 4 times in a single generation. No other source of energy has ever become so dominant so quickly. United States petroleum production. In 1920, the United States produced more than two-thirds of the world's oil. Since then, many other countries have developed oil resources. Since 2011, the United States has been the world's top producer of natural gas. Since 2013, it has been the world's top producer of petroleum hydrocarbons. Oil and gas are found in sedimentary basins in Earth's crust. To find oil, geologists search for these basins. Most of the basins in the United States have already been explored and exploited. The United States is the most thoroughly explored country in the world. Some people estimate that the United States has less than 35% of its original oil remaining. There is not nearly enough easily recoverable petroleum in the United States to meet the demand, although domestic production will continue for many years to come. Oil and gas resources are not evenly distributed in the United States. The top 10 oil fields account for 33% of all remaining oil. This includes a field in California that was discovered in 1899. Texas has been the largest producing state since the late 1920s. At that time, it surpassed California. In the late 1980s, Alaska rivaled Texas. Changes in United States production since 2000. In the United States, new technologies have enabled the recovery of hard-to-get oil reserves. This is largely due to advancements in horizontal drilling and hydraulic fracturing. In 2005, production of tight oil in the United States was less than 400,000 barrels per day. By 2015, this value increased to more than 3.5 million barrels per day. Tight oil supplies about 52% of the total United States crude oil production. The Bakken Field in North Dakota and the Eagle Ford Shale in Texas are two major areas that contribute more than half of tight oil production. Together, the United excuse me. Together, the United States and Canada are currently the world's largest producers of crude oil from tight oil formations. Geoscientists are looking to extend the production of other large basins that contain tight oil. At a global scale, analysts have calculated that fracking and other recovery methods could unlock over 100 billion barrels of new global oil supplies. Despite the benefits that additional energy resources bring, several environmental issues must also be considered. For example, fracking requires millions of gallons of water. These fluids must be recycled carefully to avoid pollution. The burning off of natural gas, or flaring, is also a source of environmental criticism. Estimates of petroleum Estimates of petroleum reserves. With only a finite volume of oil on Earth, it is important to estimate global reserves. Available reserves can be used to predict when world petroleum production will start to level off and then decline. This is a very difficult task. However, because the demand for oil and petroleum products such as gasoline is likely to keep on rising, eventually there will be a growing shortage of petroleum. At the end of 2016, the total proved oil reserves for the world reached 1,650 billion barrels. This is considered enough to meet global production for over 50 years. Proved reserves are only the reserves that can be recovered in a cost-effective way. Typically, when oil prices rise, then total proved reserves also increase. This is because the recovery of less accessible reserves, such as those in deeper water or remote parts of basins, becomes economically viable. Higher prices justify the use of more expensive technologies to reach less accessible molecules of oil. However, there are many regions in the world that have not yet been explored in detail that may contain future oil reserves. Future oil plays. Areas for oil exploration and production are called plays in the oil industry. See Figure 9. The major plays now lie in deep offshore areas of the oceans. These areas are the last major exploration frontier. The need for oil is also creating debate. The issue is whether or not to drill in areas with ecosystems that may be affected by drilling. For example, the Arctic National Wildlife Refuge lies along the North Alaskan coast. It is the largest protected wilderness in the United States. It is believed to contain billions of barrels of oil and natural gas. People that are against drilling, excuse me, I have to find my spot. People that are against drilling are afraid that it would severely affect wildlife. Tens of thousands of caribou migrate to this area every year to give birth. Those who support drilling argue that new drilling techniques will have little impact on wildlife. Which argument wins will depend on the balance between new technologies and social regulations. In the near future, petroleum production will level off and start to decline. This will occur slowly. Because demand is likely to keep on rising, there will be a growing shortage of petroleum. This will have to be made up by use of alternative energy sources. Solid organic matter is found in certain sandstones called tar sands. It is also found in certain shales called oil shales. Techniques have been developed to extract and convert the matter into usable oil. Tar sand and oil shale areas are already producing petroleum. They will be a major factor in the future energy production. Canada is especially rich in tar sands. There are abundant oil shales in the western United States. Developing fuel efficient vehicles and finding ways to conserve fuel will also help to address the shortage of petroleum.